Okay, hello and welcome to part one of the webinar series, Teaching State Machines and Control Logic with Simulink and Stateflow. My name is Michael Carone. I am the product manager for Stateflow. And today we're going to be talking about state machines and Stateflow. So we'll start off by giving a brief description of what is a state machine for anybody out there who might not be familiar with the concept. And then we'll talk about Stateflow and how it can be used to model state machines. Okay. After that, we'll talk about the case study that we'll be using throughout this webinar series. And what we're going to be doing with that case study is using it to build a stateflow chart from scratch. So that at the end of this webinar series, you should be familiar with the most important stateflow concepts. Okay, so as I mentioned, this is a three-part webinar series. So this is part one. And in this first part, we're going to cover the very basics of stateflow. So states, transitions, flowcharts, and in parts two and three, we'll go into some of the more advanced topics. All right, so before we go on with the rest of the presentation, let's actually go into MATLAB and Simulink and Stateflow and see this demo and Stateflow in action. Okay, so here's the Simulink model that we'll be using. Okay, and there's a Stateflow chart inside of it. So let's open that. So here's Stateflow. Okay, and what I'm going to do is start running this model. We're actually controlling it we're controlling the Simulink model from this GUI that we've created. And what this is a model of, it's, consider a generic plant that is, in an environment that might be hot, okay? And we need to make sure that our plant doesn't get too hot. Okay, so a number of examples of this. Think of a computer processing chip that you want to make sure stays cool. Okay, so number of examples that this can apply to. Okay, and what we're using Stateflow for is to control the fan system. Okay, and if the plant gets too hot, maybe we turn on one fan. If it gets even higher than that, we could turn on another fan or maybe make it faster. There's a number of things we could do. Okay. So in Stateflow, we're got a few different states in here. So for example, just very basically, we have a device that could be either off or on. If I turn on the device through this GUI, you can see that it's switched from off to on. Okay, so this highlighting tells me what's the active state in any given time. All right. If I go up and let's say I raise the temperature. Okay. Right now my fan is in the fan low state, but now with the temperature of the device rising, which you can see from that gauge, now the fan has transitioned to the fan high state. Okay, so now the fan is high, which is cooling, and once it got cool, you could see it switched back to the fan low state because the plant had gotten cool enough. But now the fan has gone back to fan high, and it keeps switching back from low to high because right now the temperature is pretty high. Okay. All right, so let's go back up. Uh, Now, so these are the different states we have in here. We also have a number of functions in here as well. For example, here is a graphical function. Okay, so this is a way to represent flow graph within Stateflow. Okay, we have a truth table. Okay, so you could create your functions with truth tables. And we're using MATLAB. Okay, so you could just use MATLAB code within your Stateflow chart. Okay, so that should give you a flavor for Stateflow and what it could do. And we'll be actually building this entire logic from scratch. Okay, so you'll see how each piece was created and how everything fits together, and how you can use it to teach state machines in your classes. Okay, so back to the presentation. Let's take a step back and talk about what is a state machine. Okay. So a state machine is a representation of a reactive system that contains a finite number of states. And the system changes states based on defined conditions. So we have an example of this in the slide. And this is an example of an automatic transmission, okay, or any transmission for that matter. So suppose you have a transmission. Actually, this one's an automatic transmission because the vehicle does the switching. So so consider a transmission that has 4 gears. Okay, each one of those 4 gears is represented by a state. Okay, and whether the transmission is in one particular state or another depends on the conditions. Okay, so the system will transition from the first gear to the second gear if in this case, the up event is true. Well, why would the up event be true? It could be that the user wants the transmission gear to change. It could be because the RPMs of the engine are at a sufficient threshold. Okay, so you would switch from one gear to another, and we saw that in the demo example as well, where the fan switched modes because of the temperature of the plant got too high. Okay, so that's one example, and we have a couple of other examples shown here. For example, a fault management system. You know, you could use a state machine to control whether a component should be isolated or turned off because that component is considered too faulty. Okay, or we could have a robot arm where the state machine can represent the different operational modes of the robot. Okay, so what is stateflow? Well, simply put, stateflow is a way to represent state machines and flowcharts within Simulink. Okay, so you could represent a number of different types of logic, including control, supervisory, and mode logic. And because the logic is, represented in this graphical form, makes it much more easy to understand than if you would have represented with, say, a piece of code. Even if you're not familiar with programming, you could look at something like this and easily understand what's being represented without needing to dig through any code there. Okay. All right, so what can you do with Stateflow? Well, we've actually covered a few of these things already. So you could use it for reactive control systems, control system logic, obviously finite state machines. Scheduling is something that we haven't mentioned yet. So suppose that you have a number of tasks that need to execute one after the other. Okay. For example, you might have an initialization phase within your algorithm. Okay. Well, stateflow could be used to control exactly when those tasks occur. Okay, so a lot of times people use it to control when their Simulink components get executed. Okay, so that's another example. We talked about fault management and obviously event-driven systems. If some event occurs, stateflow could be used to react to that event. Okay, for example, a component failing. All right, which industries stateflow used? Well, it's heavily used in the automotive industry. Example is we already covered the automatic transmission system. Another example here is the logic for your lighting system. Okay, so when you open your car door, a number of lights might turn on, but that could be dependent on whether the key is in the ignition. Okay, all of that logic is usually described with a state machine. Okay, another example industry here is aerospace and defense. So what's shown here in the picture is a rocket being lifted off, and a rocket goes through a number of different stages as it travels through the atmosphere, and those different stages can be represented with states. Okay, we already covered this example with the robot and different operational modes. So Stateflow is also used in industrial automation and machinery industries. And last here is the communications industry, and using Stateflow um, to model the logic of a wireless protocol. For example, any of the Bluetooth or 802.11 G protocols. Okay, so how do those packets get sent from one place to another? There's a lot of logic involved in that. Okay, and Stateflow has been used to model that logic. Okay, here's a sampling of organizations that have made use of Simulink and Stateflow, and it's pretty wide-ranging. You have places like NASA, Toyota, Ford, Motorola, a number of educational institutions here like Penn State and Rose-Hulman. Number of organizations have made use of Simulink and Stateflow, and if you are interested in learning more about how these particular organizations have applied Simulink and Stateflow, we have user stories on our website that describe it in great detail. So if you're interested, I encourage you to check that out. Okay, so just to go back, why teach Stateflow? Well, as we've seen here, is Stateflow is a widely used product in industry. So that's one, and two, it could be used to illustrate conceptual logical problems in a graphical, easy to understand way. So when you're teaching it, you don't have to get caught up in any code. You could use the graphical way and illustrate the any state machine or logic problems in a way that's much easier to grasp, and so you don't have to wrestle with any of the code issues there. All right, so now let's talk about the case study that we'll be looking at. So what we're going to do is look at a device that generates heat when it's switched on. Okay, so the operator presses the button to turn it on, and then some heat is generated. And so what we're going to do is find a way to dissipate that heat. So we're going to have a fan system, and we're going to develop the logic for controlling that fan system, okay, and also for controlling the operation of the device. All right, so we'll do a number of things. For example, turning the fan on or off, determining what should be the appropriate speed of the fan, what happens if a primary fan fails. If we have a backup fan, how could we activate that? And also having some type of automatic mechanism for turning the device off if the temperature of the device gets too high. Okay, so I've just circled a number of different items in here which would lead you to believe that Stateflow would be an appropriate choice for designing this type of system. Okay, so let's open the model. Okay, so this is the model that we're going to be working with. So before building up our Stateflow chart, let's look at the model first, and just so you understand how it works and some of the different pieces that have already been developed. So one piece is the model of the fan. Okay, so we have a primary fan and a backup fan. And let's look at the primary fan. And we've built this using physical modeling blocks. For example, a DC motor, a number of sensors, voltage source. Okay, so this represents the fan that will be used to cool our device. Okay, and we use the same type of system for our backup fan. All right, that's connected to a temperature model block. So if I open that, what we've done is we've derived the temperature of the device using some principles of thermodynamics, where the input values are the ambient temperature and how much the device is being used, whether or not the device is on, and so on. Okay. So that gives us the temperature of the device, and that's sent to a scope block so we can monitor the temperature throughout time. And then it's sent to a gauge block so we can see the temperature at any given time. And then on the left, we have a number of switches. The top switch is to turn the device on or off, and then we have switches to turn the primary and the backup fans on or off. Right. And last here, we do have a GUI that we created using Guide, which stands for GUI Development Environment, that comes with MATLAB. So this is used to control the behavior of the switches. So if I click on or off, you can see that this switches the device on or off. So there's MATLAB code that we created in order to do this. And I could also control the ambient temperature, and once the device is on, I could also control how much the device is being used, what's its usage level. You can see that impacts this gain block that's over here. Okay. Last thing in this GUI is sim speed, so I could control how fast the model runs. I'm just going to leave it at its highest value so we can run it as fast as we can. Okay, so let's start building the Stateflow chart. So what I'm going to do is go into the library browser and go to Stateflow and drag a chart into our model. All right. And so here's Stateflow. And first thing we need to do is represent the main states of our system. So what are the top level states? All right, so this is usually how I build the Stateflow charts, as I go from the top level and work down. All right, so I know that the top level states of this device, it'll either be on or off. All right, so I'll represent those two modes or states with a state. So there's the state object. So we have device off. And device on. All right, so what I've done is created two exclusive states. What that means is that the device can only be in one of these two states at any given time. All right, so it can't be both off or on at the same time. All right, now I need to define how does the system transition from one state to another. All right, so how do we go from off to on and from on to off? So I represent that using transitions. So if I drag over here and my arrow turns into a crosshair, that means that I could define a transition. Let's click here, go from off to on, and from on to off. All right, so now I've created two transitions, and if I were to run this model now, what would happen is at each time step, the state machine would go from off to on, and then the next time step, it would just go from on to off. So it would just keep oscillating between one and the other. That's not what we want to happen. We want the device to turn on when the operator switches the device on. So to do that, I'm going to guard these transitions using conditions. Okay, so I've now created two conditions. So condition, the syntax, you represent a condition using square brackets. Okay, so if you see square brackets, you know it's a condition, and the condition says switch on. So within the square brackets, that expression, whatever is in there, if it evaluates to 1, okay, then that transition is going to be taken. If it evaluates to 0, then the transition will not be taken. Okay, and here we have a not symbol next to switch on. So that means if the switch is off, then the device is going to be turned off. All right, so I actually need to define what happens when the device is turned off or on. Okay, so for that, I'll define a state entry action. Okay, so on entry into the device off state, the variable device on will be set equal to 0. And on entry into the device on state, device on variable will be set equal to 1. Okay, and last thing I need to do is define a starting point for the stateflow chart. If I were to run this model, stateflow would not know where to begin. Does it begin in the off state or does it begin in the on state? So we want it to begin in the device off state. So I'll create a default transition. Okay, so that gives you your starting point. This is also helpful if you're looking at somebody else's stateflow chart. I recommend always starting by looking at where the default transition is. So that gives you your starting point, and then you can analyze the logic from there. Okay, so at this point, we're ready to run our model, test it out. Let's go to Start Sim. And we're not quite ready because we haven't defined our variables device on and switch on. Okay? There's also no interface with Simulink at this point. If I were to go to the Simulink model, you can see our chart's just hanging out there and it's not connected to anything. Okay, so let's go to our symbol wizard. And what this allows me to do is it analyzes the your state chart and it looks for any variables that you've used that you have not yet defined. Okay, so it tells you what those variables are and it allows you to define those variables within the wizard. Okay, so we have device on, that's an output variable, and switch on is an input variable. And so I've checked them both, so that means I want to create them both. And I just press the create button. Now if I look at the Simulink model, I can see that there's an input and an output port on my stateflow chart. I can drag it in here, and now it's connected with my Simulink model. So now, if I try running it, now the model is running. Okay? And what happens when you run a model that contains a stateflow chart, if you look at the diagram, you can see that there's highlighting. So right now device off is highlighted. That means it's currently the active state. And if I were to go to the GUI and switch the device on, then the device turns on. Okay? And if I go back, it goes from off to on, and so on. Now this is a very simple state chart, but imagine that you had something that was more complex. This animation is very helpful in helping you see exactly how the logic in the state machine is behaving. Okay, so you could watch the animation take place, and it's very helpful also for debugging purposes. You know, you might look and watch the simulation run and see that a state that you thought would be activated was not activated, and the animation helps you determine why that's the case. Okay, we could also see that the Simulink model is working, where you could see the gauge showing that the temperature is 152 degrees when the temperature gets pretty hot. Okay, next what we want to do is turn the device off if the temperature gets too high, right? Right now, the device only turns off if the operator switches it off, right? So we want to put in an automatic mechanism so that it's turned off when the temperature is too high. So to do that, we're going to create some complex transitions. So the device will turn on when the operator turns it on and the device is cool. And it will be switched off if the operator switches it off or the device is not cool. Okay, so I've now created a complex transition using the ampersand symbols and the vertical lines here. So we define another variable here, t device in this case. So we have to define that. Now before we used the pattern wizard, that was convenient because you could define multiple variables at any one time. We could do that again, but I'm going to show you another way you could define your variables. If you go to add and data, and then say input from Simulink, type in t device. It's okay. And go back to our window, and now you can see t device is an input variable to the stateflow chart. Right. And let's feed that back in. And there it is. Okay, so things are starting to get a little bit cramped here, so I want to make things a little more compact. So I'm going to create a super state for device off and device on. Let's drag a state in here. We'll call it device logic. What I'm going to do is expand it so that it contains device off and device on. Okay, move things down a little bit. Okay, so now I've created some hierarchy where device logic is a super state containing device off and device on. And then I'll right click, say make contents subcharted. This is like in Simulink when you create subsystems, you could create subcharts in Stateflow, and now I've hidden the details. And if I double click, I can see underneath. Okay, so that's useful for when you're developing, pretty complex state machines. You can create this type of hierarchy and hide the details of your state charts and subcharts, so you can create things that are pretty complex. Okay, so let's create this function is cool, right? We need to define a function for that. So now we're going to do this using a graphical function. So we're going to define our function using a flowchart. Okay, so that's this icon here. Drag that in. And status is the output, and it's called is cool. Input will be t. Right, and I'll do a similar thing that we did for device logic and make that subcharted. Okay, double click. All right. So what this function is essentially going to be is just an if-else statement. We're going to say if the temperature is less than or equal to a certain value, set status equal to 1, meaning that it's cool. Else status is going to be equal to 0, meaning it's not cool. So let's define this flowchart using the patterns wizard. So the patterns wizard can be used to define a number of flowchart constructs. Okay, so we have if else, we have some loops, a switch statement. In this case, it's just a simple if else statement. Okay, so there's an optional description here. I'm going to skip that. There's an if condition, so I'm going to say when temperature is less than or equal to 160 degrees. When that happens, we'll set status equal to 1. else status equals 0. Okay, and there's the flowchart. Okay, so let's review the flowchart that gets generated from the pattern wizard. And the best way to review it is to start with the default transition. That's our starting point. Okay, so we start with the default transition, get to a junction. And what's a junction? Junction is essentially a decision point. Okay, so when Stateflow hits a junction, it needs to take one of the outgoing paths from that junction. And so what Stateflow will do is it will look at the different outgoing paths one at a time, and it decides its order based on this numbering system that's created here. So first, it'll check this transition because that's labeled with the number 1. Okay, so that's the highest ranked priority. So first, it's going to check and see if temperature is less than or equal to 160 degrees. If that's true, then it will proceed along this path. And if it proceeds along this path, then status is going to be set equal to 1. And you see this is another concept introduced. This is a condition action, okay? And that's represented by these curly braces. So when you see curly braces, you know that that means it's an action, okay? Whereas with square brackets, that's a condition, okay? If temperature is not less than or equal to 160 degrees, then it's going to take another path. And the next path is here, and that's just a simple else. It's not going to check any other conditions. It'll just set status equal to 0. Okay, so that wraps up part 1 of our webinar series. Now let's talk about some of the concepts that we've covered here in this first part. So first we saw the exclusive states with device off and device on. Right? The state chart can only be in one state or another. Then we saw transitions. How do you connect different states together? Right? That you use transitions to do that. Then we saw how you could use conditions to guard the transitions. So when a condition is true, that's when the transition is taken from one state to another. We saw state entry actions. So there's an action that takes place upon entering a state. We saw default transition. That's your starting point in your Stateflow chart. We saw the interface with Simulink and how you connect your Stateflow chart up with your Simulink model. We saw the symbol wizard, which is a convenient way to define a number of variables in the Stateflow dictionary, data dictionary at any one time. We saw complex transitions where we used the ampersand signs and the vertical lines to define ands and ors. We saw hierarchical states where you can contain certain states within superstates. We saw subcharts, which is similar to the concept of subsystems within Simulink for hiding the details of your different states. We saw one of the types of functions, a graphical function, which is used to define functions using a flowchart. And last, we saw transition priorities, where we had the junction and different paths that it could possibly take, and it decides which condition it's going to check by looking at those transition priorities, which are represented by the numbers on the transitions. So if you're interested in learning more about Stateflow and who's using it, and maybe dive into some of the details, you could go to the Stateflow product page, and we have a number of user stories there. We have a number of demos there as well. So if you want to see some of the different applications for which you could use Stateflow, you could see that all on the website. We do have a training course for Stateflow. So this is only an overview. We're kind of doing a broad brush over the concepts, but if you really want to get detailed, comprehensive understanding of Stateflow, we do have a training course available. It's one full day, and the details are listed here on this link. And this is just part 1 of our webinar series. So if you want to see parts 2 and 3, you can go to the product page and click on demos and webinars, and you will see it listed there. Or you could just follow the link that I've shown here, and that will also take you to the list of recorded Stateflow webinars. And if you're interested in an on-site demonstration of Stateflow, please contact your MathWorks account representative. So with that, we're going to go offline for a couple of minutes and gather any questions that you might have.